By the end of this video, you'll understand how CQRS works and how to use it in a real-world application. We will build everything step by step, including filtering, pagination, and validation. CQRS means Command Query Responsibility Segregation. It separates write operations from read operations. Instead of one model, we divide our system into two paths. First, commands. These handle write operations like creating, updating, or deleting data while enforcing business rules. Second, queries. These handle read operations like fetching data. By separating both sides, we can scale, optimize, and secure them independently, making application faster, scalable, and easier to maintain. As you can see, I have already created an MVC Web API project. I have also installed the required entity framework or packages and created the product entity and product DTO. Now, let's install the MediatR library. MediatR helps us implement the CQRS pattern by separating our commands and queries from the application logic. Let's organize our application in a better way by separating our commands and queries. This structure will make our code cleaner, easier to manage, and follow the CQRS pattern properly. Now, let's create a class named createProductCommand. And this class is used to carry the data required to create a new product. iRequestProductDTO means this command expects a response of type ProductDTO after it is handled. Inside this record, we specify the properties that are used for creating a new product. Inside the same folder, create the createProductCommand handler class. This class is responsible for handling the createProduct command and contains the logic for saving the new product into the database. Then, implement the iRequestHandler interface to connect this handler with MediatR. The iRequestHandler interface expects two types, the command it handles and the data type it returns. Now, let's register MediatR in our application. This allows MediatR to find our commands, queries, and handlers automatically. After registration, MediatR can connect each request with the correct handler and execute the required logic. Let's execute our command inside the controller. First, create a products controller class. This controller will receive API requests and use MediatR to send commands and queries to their corresponding handlers. Here, we create a post endpoint to add a new product. The create product command receives the product data from the request body. Then, MediatR sends this command to the handler to create the product. Finally, we return the created product data. As you can see, the create product endpoint is working correctly. Now, let's implement the update product command. This command will be used to update an existing product. It will receive the product ID and the new product information, then send this data to the handler to update the product in the database. Create the update product command handler class to implement the iRequest handler interface. This handler is responsible for receiving the update product command, processing the update logic, and returning the updated product data. Create the update product method inside the controller. This endpoint receives the product ID and update data from the request body. First, it checks if both ID match. Then, it sends the command to MediatR to update the product. If the product is not found, it returns a not found response. Otherwise, it returns the updated product data. Now, let's run the application and check whether the update method is working correctly. We will send an update request and verify that the product data is updated successfully. Let's create a new class named deleteProduct command. This command will be used to delete an existing product. It contains the product ID that we want to remove from the database. Create the deleteProduct command handler class, which is responsible for handling the deleteProduct command. This class contains the logic for finding the product by ID, removing it from the database, and returning true after the deletion is completed. Add the deleteProduct method inside the controller. This endpoint receives the product ID and sends it to MediatR. If the product is not found, it returns a not found response. Otherwise, it returns a successful response with no content. As you can see, it's working correctly. Now, we are going to implement the query part. In this section, we will create queries for retrieving data from the database and separate them from our commands. Create the getProductById query class, which takes the product ID as input, and return the product DTO as a response. Create the getProductById query handler class, which is responsible for handling the query. This class contains the logic for finding a product by its ID from the database and returning the product data as a product DTO. Add the getProductById method inside the controller. This endpoint receives the product ID and sends it to MediatR. If the product is found, it returns the product data. Otherwise, it returns a not found response. Create the getProducts query class, which is used to request all products from the database. Now, create the getProductsQuery class, which is responsible for handling the getProducts query. This class contains the logic for retrieving all products from the database and returning the product list as a response. Let's add filter and pagination to our products. So, create a product filter class. Here, the search property is used to search products by name. The min price and max price are used to filter products by price range. The page number and page size properties are used to control pagination. Create the page result class. This class is used to return paginated data. It contains the items list, the total number of records, the current page number, the page size, and the total number of pages. This gives the client all the information needed for pagination. Inside the Get Products query record, specify the product filter. This filter contains the search and pagination values that will be used to retrieve the required products. Here, first we filter the products based on the name and price range. Then, we count the total number of products that match the filter. After that, we apply pagination to get the required products for the selected page. Finally, we return the products along with pagination information using page result. Update the getProducts method in the controller to apply filtering and pagination. As you can see, the filtering and pagination are working correctly. We can search products, filter them by price range, and retrieve the results page by page. Everything is working as expected. We are going to validate the create and update operations using the FluentValidation library. Let's install the FluentValidation library and its dependency injection extension package. These packages allow us to create validators and register them automatically in our application. Add the Create Product Command Validator class inside the Create Product folder. It inherits from Abstract Validator class. This allows us to define validation rules for the Create Product command properties, such as checking the product name, description, and price before creating a new product. Now, inside the constructor, define validation rules for each property. These rules check the product name, description, and price before creating a new product. For example, the name is required, the description has a maximum length, and the price must be greater than 0. Add the Update Product Command Validator class inside the Update Product folder. Add the validation rules inside this class. We validate the product ID, name, description, and price to make sure the updated product data is correct. These rules will run before updating the product and prevent invalid data from being saved. To apply this validation in a better way, we are going to use a mediator behavior. This allows us to run validation automatically before executing any command or query handler, keeping our controllers and handlers clean. Add the validation behavior class inside the behaviors folder. This class runs validation before executing commands. This class implements a pipeline behavior. TRequest represents the command or query, and TResponse is the returned data. And inside the handle method, we run the validators and collect errors. If validation fails, we throw a validation exception, otherwise, we continue to the handler. To handle this validation exception, we need to create a custom exception handler. Add the validation exception middleware class inside the exceptions folder. This middleware handles validation errors. It runs the next middleware using _next. If a validation error happens, it catches the exception and returns a 400 response with the error messages. Register the FluentValidation service in application. This scans the project assembly and automatically registers all validator classes. Register the mediator validation pipeline behavior. This allows our validation behavior class to run automatically before executing commands and queries. Add the validation exception middleware to the application pipeline. This allows the middleware to catch validation errors and return a proper response to the client. Now, let's run the application and test the validation. We will send invalid data and check if the validation errors are returned correctly. As you can see, our validation is working correctly.